Okay, so I'm going to demonstrate here how to do a two-way factorial ANOVA with replication in Excel. A two-way factorial ANOVA you would use when you have two independent variables that you're examining and you want to see what the effects are on a dependent variable as well as the interaction of the effects of those two independent variables. How to decide whether to use with replication versus without. With replication in this case refers to having multiple groups. So in a case where you have multiple independent groups, then you would use with replication. Without replication is where you have repeated measurements on a group of individuals. So that would be a repeated measures ANOVA, which we're not discussing here, but that's what you'd use if you'd use the without replication function for that type of analysis. I know that seems switched, but in this case, with replication means that you have multiple groups, whereas without replication, you would have, for example, one group, but multiple measures taken on each subject. Okay, so here's what the data would look like, and I've organized it in the way that you need to organize it if you want to run this analysis. One independent variable, so this is just some made-up data. Let's say we're doing a study on older and younger adults, and they're doing some game that either a group either plays a high difficulty game or a moderate difficulty or a low difficulty version of the game, and then the ratings in here are, say, the level of enjoyment that they report. And we've got 11 subjects in each of these groups. Okay, so one independent variable would be age, and the other independent variable would be difficulty. This independent variable has two levels, older and younger, and then the independent variable of difficulty has three levels, high, moderate, and low. Okay, a good idea, I think, first is to get a better feel for what your data looks like, and probably even to plot it. Here I've just plotted some averages for high difficulty, moderate, and low difficulty. You can see what I've selected here. Here you can see we've got maybe some differences here. Here are the younger subjects here. I can just copy and paste this formula. See, we've got probably a big difference there. Let's just do a couple of bar charts here real quick. Of course, you want to add labels, chart titles, and everything. But just to get a quick visual of the data and what it looks like and what we might expect to find. So here are the older I'll just label these older and younger so we can keep them straight. Of course, you'd want to add more labels than just these if you're adding a chart in a publication or an assignment. So you can see that we got a similar pattern in each one, but it is a little bit different. There's definitely some differences that we're showing, and when we look at the output, we can kind of see if that makes sense based on what we're seeing. Okay, so to run the analysis, you'll go to the Data tab, Data Analysis, and then do two-factor with replication. Okay, we'll select the input range. You want to select all of the data, including the labels, and here you want to specify the number of rows per sample. So the Excel calls the two levels of this independent variable that's used to organize the rows, the two samples, or the samples, okay? So you can have more than just two. In this case, we just have two, but each one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rows. So we would put 11 rows in here per sample. There's 11 rows for older and 11 rows for younger, and alpha we'll leave at 0.05, the default. The output range, we'll go ahead and select this right here. And we will, let me do just a little bit further over here. And we will click OK. All right. Now, it's often good to just check and make sure your averages are matching up, just to make sure you've calculated everything right. So in this summary table here, these summary statistics, they tell you the count, and that's what we expect, 11 in each group. And then you've got the averages, which you can see we've repeated here. So that's reassuring to know that we've selected the data and Excel is reading it right. Here is the meat of what you want to look at, this ANOVA table here. Okay, so you have sample, columns, and interaction under these sources of variation. Okay, now these right here are your main effects, and this is your interaction. And there's an F statistic associated with each one. Okay, the main effect of sample, that's examining whether there is an effect of this independent variable if you were to average across these ones. So if you're just comparing older versus younger, is there a difference on average between older and younger if you're only looking at that? So you can see that there is a relatively high F statistic here and a low p-value. So that is statistically significant according to our threshold, and so we would say there is a main effect of age. There's a main effect of age in this ANOVA. Okay, the columns, that's asking about your other independent variable, the one that's organized, the one that's used to organize your data into the different columns. So we got those 3 levels of difficulty, and you could average across all of your subjects, all of your older and younger, kind of collapse across those and just get some averages there. And then you could basically just do a one-way ANOVA and compare those, and that would be analogous to this main effect. Okay, so this is a main effect of difficulty right here, and you can see that this one is also statistically significant. Very high F and a very low p-value, 1.32 times 10 to the negative 7th power. Okay. And then usually in a factorial ANOVA, the number that you're really interested in, the analysis that you're really interested in, is this interaction. Okay, so that's saying, do the differences between the 3 difficulty levels depend on whether you're looking at older or younger. So the question that's answered with the interaction is could also be phrased as, if you were to draw lines from mean to mean to mean, and if you were to kind of place them next to each other, would these 2 lines be parallel? So the differences between high, moderate, and low difficulty, if someone asks you, hey, is it the same, whether those differences, whether the same, whether you're dealing with older or younger participants, if you would say, well, it really depends on whether you're talking about younger versus older, it's different. Then you have a significant interaction. And that's often what you're really interested in when doing a factorial ANOVA. Okay, and so we can see that right here, this F statistic is sufficiently large that you get a low p-value below 0.05, so there would be a significant interaction between difficulty and age, a significant, sometimes it's phrased an age by difficulty interaction. Okay, so those are the relevant statistics results that you'll get from the output. And